Hi Andy, name is Priyanka. Welcome to Learning Lens channel. Today we are going to discuss graph of a quadratic polynomial. What is a quadratic polynomial? A polynomial of degree 2 is called a quadratic polynomial. Let's write the quadratic polynomial. P of x is equal to ax square plus bx plus c, where a is not equal to 0. Here a is not equal to 0. What is a quadratic polynomial? Ax square plus bx plus c, a is not equal to 0. This is the general form of a quadratic polynomial. So if a is 0, what happens? 0 into x square plus bx plus c. So what happens? It will become a linear polynomial. So a should not be equal to 0. That's the reason a should not be equal to 0. So now we are going to draw the graph of a quadratic polynomial. So let's draw the graph of a quadratic polynomial. So how the graph of a quadratic polynomial will looks like? It looks like a parabola. So it's look like a parabola. So here what is the condition given? A is not equal to 0. Means a is not equal to 0 means it can be greater than 0 or less than 0. So a not equal to 0 itself, it is saying a can be greater than 0 or a is less than 0. So if a is greater than 0, there are three conditions, that is d greater than 0, d less than 0 and d equal to 0. So what do you mean by d? D is nothing but discriminant. D is nothing but discriminant. So discriminant delta is equal to b square minus 4ac. So what is the formula for discriminant? b square minus 4ac. Means we have to compare ax square plus bx plus c equation with the given equation and we need to substitute this. Then we should determine d is greater than 0, less than 0 or equal to 0. So again for a less than 0 also there are three conditions, that is d greater than 0, d less than 0 and d equal to 0. Let's take one example to verify how we can take d greater than 0, less than 0 or equal to 0. So example is x square minus 3x minus 4. So let us compare this equation with the general form of the quadratic polynomial, that is ax square plus bx plus c. So what is a value here? Nothing is there, so assume it as 1. What is b value? B is equal to minus 3. What is c value? C is equal to minus 4. So delta is equal to b square minus 4ac. B square minus 4ac. So what is b value? Minus 3. So minus 3 whole square minus 4. A value how much? 1. C value minus 4. So when the power is even, so 2 is even power. So it will come positive. Minus 3 into minus 3 is plus, minus into minus plus. So 3 into 3, 9. Minus into minus again plus. 4 into 4, 16. So 25. 25 is greater than 0. Means here d is greater than 0. Means we need to, we got what we got here, d is greater than 0. For d greater than 0, we need to draw the graph. So like that, if you take examples, in some cases we will get d greater than 0 and in some cases we will get d less than 0 and in some cases d equal to 0. So based on these values, we are going to draw the graphs. Okay, let us draw the graphs of the quadratic polynomial for d greater than 0, equal to 0 and less than 0. So for I am taking the condition a case 1, that is a is greater than 0. For a is greater than 0, I am drawing three pictures, that is d greater than 0, d equal to 0 and d less than 0. Okay, so let us draw the figure. That is, this is x-axis, this is x dash, means negative axis, y dash, negative y-axis, positive y-axis. So positive axis we will represent with x, y, and negative axis we will represent as x dash and y dash. Let it be 0, 0, that is origin. So this intersection point is nothing but O0, 0. So what is the graph of the quadratic polynomial p of x is equal to ax square plus bx plus c. So we are going to draw the graph of the quadratic polynomial ax square plus bx plus c equal to 0, that is when a greater than 0. So we are drawing the graph when the condition is a greater than 0 and d greater than 0. So how the graph will look like? It will look like this. So here it is touching the x-axis at two places, 1 and 2. Means here it is touching the x-axis at two places, 1 and 2. So how many intercepts we will get? 2 x-intercepts. Means how many zeros we will get here? 2 zeros. So where the graph will intersect the x-axis, there we need to take the x-intercept. That is called the 0 of the polynomial. So here 2 x-intercepts are there. So number of zeros are 2. So how many zeros here we will get? 2. How many x-intercept? That many zeros. Okay. Next, d equal to 0. So for d equal to 0 condition, same x-axis, x dash, y dash, y-axis and origin 0, 0. So here the graph will intersect the x-axis at only one intercept. So here one repeated x-intercept, Here we will call it as double root. So the one intercept only will come double times, that is one repeated x-intercept. So here how many zeros? 1 0. And d less than 0. For d less than 0, y dash, x dash, y. So origin 0, 0. Here the graph will look like this. Means here the graph is not intersecting the x-axis at any place. So it is not at all intersecting the x-axis. So here we will get the no intercept. No x-intercept. So no x-intercept. So how many zeros here we will get? No zeros. Why? Because the graph is not intersecting the x-axis at no place. So here there is no x-intercept. So no zeros. Okay. So in d greater than 0 case and in the a greater than 0 case and again in the d greater than 0 case, how many x-intercepts are there? 2. So number of zeros 2. So in d equal to 0 case, how many x-intercepts? 1 x-intercept. So how many zeros? 1 0. And in this case, is there any x-intercept? No, we are not having any x-intercept here. So number of zeros are no. Okay, next topic. Okay, next we are going to discuss now the second case, that is a less than 0. So for a less than 0, again three conditions, that is d greater than 0, d equal to 0 and d less than 0. So let's draw the graph for the quadratic polynomial. So x-axis, x dash, y-axis, y dash and origin. So here the graph will come like this. Means downward parabola. When d is greater than 0. So how many intercepts here we got? 1, 2. So 2 x-intercepts. 2 x-intercepts. So how many zeros here we will got? 2 zeros. Number of zeros 2. Number of zeros how many? 2. So we got here 2 zeros. Now let's discuss for the second condition, that is d equal to 0. X-axis, x dash, y dash. So here the graph will come like this. Means here also it is intersecting the x-axis at one place. So here we will got one repeated x-intercept. So number of zeros 1. One repeated x-intercept. So how many zeros here we will get? 1. So number of x-intercept, that is the only answer for the number of zeros, that is 1. So for d less than 0 condition. For d less than 0 condition, x-axis, x dash, y-axis and y dash. Here the graph of the quadratic equation is looks like this. So here also it is parabola. So here it is not intersecting the x-axis. So here no x-intercept. So no x-intercept means no zeros. Okay. Let's discuss one more time. When a is greater than 0, we will always get the upward parabola. When a is less than 0, we will always get the downward parabola. So in the a less than 0 condition, again we will get 3 cases: d greater than 0, equal to 0 and d less than 0. In d greater than 0 condition, here we are getting 2 x-intercepts, 1 and 2. So 2 x-intercepts, so number of zeros are 2. In this condition, we are getting only one x-intercept. So number of zeros 1. In this condition, we are not getting any x-intercept. So no x-intercept means number of zeros are 2. Okay, understand?